Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. All right, lesson 14, graphing the tangent function. So I have the equation. What is tangent? Well, tangent of x equals the sine of x divided by the cosine of x for cosine of x not equal to 0. We can't divide by 0. So we're switching though. We have the set, okay? This defines the function. We're going from degrees to radians. All right, so we're going from the set of all theta in the set of reals such that theta does not equal 90 degrees plus 180 degrees times k. So if I take 90 plus 180 times k is 1, I'd be here. Oh, by the way, if k is 0, we're here. If k is 1, we're here. If k is 2, we're here. If k was 3, we're here. So we're going to just be bouncing back and forth here, and that is where cosine is 0. Okay, and that's where cosine can't be 0. So we're switching from that to the set of all theta in the set of reals such that theta does not equal pi over 2 plus k times some pi for all integers k. Well, pi over 2 is right here. Add a pi, we're going halfway around the circle, we're there. 3 pi over 2, 5 pi over 2, 7 pi over 2, 9 pi over 2, and so on, and so on, and so on. So we are just changing the parameters from degrees to radians, okay? And cosine cannot be 0. But what is tangent? Well, tangent is a line that is perpendicular to the terminal ray at a point on the unit circle where it just touches like so. The tangent is actually the slope of that line perpendicular to the terminal ray. So if I move this terminal ray up to pi over 2, then my slope would be like so, okay? If I move my tangent over here and my terminal ray is 0, then this would be my tangent here. Okay, so we are going to be taking the tangent, but tangent is y over x, and it's undefined here and here. Okay. Okay, so I need to be a little more clear about that. Let me put that tangent line back. So we're not taking the slope of the tangent line. If our tangent line is here, the slope of the terminal ray is what we're taking, is what the tangent is. So the slope of the terminal ray here is 0. And the slope of the terminal ray up here, let me just flatten this out like so and bring this up here. So in other words, if the terminal ray were up here, it is perpendicular, the terminal ray. So if the tangent has a slope of 0, the terminal ray being perpendicular would have a slope of undefined because it's vertical. And over here, if the tangent had a slope that's undefined and the terminal ray is perpendicular, then the terminal ray has a slope of 0. So the slope of this is positive right now. So it's positive in the first quadrant. The slope would be negative in the second quadrant, positive in the third quadrant, and negative in the fourth. Okay, so let's now move on to what we're going to do in this lesson. I just wanted to bring up, I could leave that, I suppose. All right, so here's the classwork. Exploratory challenge, exercises 1 through 5. So this is a group activity in a classroom, and there are 4 groups. And what we're doing is we're breaking up the unit circle. And this one is going to go from negative pi over 2 to pi over 2. So that's going to go from, let me bring that unit circle back. Negative pi over 2 is right here to pi over 2. So we're talking about the right half of the circle. pi over 2 to 3 pi over 2 is the left half of the circle. And this group is doing negative pi over 2 to negative 3 pi over 2. And this group is going to do 3 pi over 2 to 5 pi over 2. And we're going to see what happens there. So the parentheses, remember when we're talking about domains, if there's parentheses, you do not include the ends. If there are brackets, they are included. So when I see this parentheses, we are not going to include negative pi over 2 or pi over 2 because we just discussed that tangent of the terminal ray at those points are undefined. So we're going to eliminate them by going from negative pi over 2 to pi over 2, not including the endpoints. So 12 pi over 24 is negative pi over 2. This is very close. It's 1/24th away from being negative pi over 2. So this says to use your calculator to calculate each value. So let me get the calculator open and go to my home screen and clear it. And it says 2 decimal places. So I would take negative 11 pi. And I like to, well, I guess I could just say divided by 24, since 24 is just a number and it's no variable. Okay, so I get negative 1.43, which would round to negative 1.44. Negative 1.44. Okay, so then I question that. And if I open my calculator back up, here, let me fix this. Okay, mode, radian degrees. What would happen if I went down and switched this to degrees? And then I just hit enter, and negative 11 pi over 24 is 1.439. Go back to radians, and it's negative 1.43. Okay, what am I not doing? I'm not doing the tangent of x. I'm just putting x in. So that's my x. So now if I do the tan of negative 11 pi divided by 24, then I'll get negative 759. Okay, now what I wanted to show was if I were in degrees, what value would I get? Okay, I get negative 0.025. All right, so just make sure you're in radians and that you get negative 7.59, which rounds to negative 7.60. All right. And we're just going to keep doing that. So I'll do one more and then I'll just fill it in. All right, so then I do the tan of negative 5 pi divided by 12. Enter. And I get negative 3.73. Okay, and we're just going to keep doing that. I'm not going to spend time sitting here doing this, but I'll give the answers after so you can check. Okay, so here are the values. Now notice what happened. If there were 4 different groups, they all should have gotten the same values for these because basically it is just going in different directions. And this was the right side of the circle. This was the left. Negative pi over 2 to negative 3 pi over 2 is the left side of the circle. And if I go clockwise, 3 pi over 2 is at the bottom at 6 o'clock, 5 pi over 2 is at 12. This is the right side of the circle. So the group 1 and group 4 got the same side of the circle, and group 2 and 3 both got the same side of the circle. We were just going in opposite directions, one clockwise, one counterclockwise. Okay, page 2 brings us to 4 more groups. Now, I brought the unit circle back in just to explain something here. Negative 5 pi over 2. So if I start here, negative means to go in the counterclockwise or the clockwise direction. So here's negative pi over 2, 2 pi over 2 or negative pi, 3 pi over 2, 4 pi over 2, 5 pi over 2 is right here. Negative 5 pi over 2 is here. And if I want to go to negative 3 pi over 2, I want to go in the counterclockwise direction, a distance of pi. So I'm going to go this way around here. So this is the domain that we are talking about. It's the right side of the circle for group 5. If I go on to group 6, that's 5 pi over 2, which would be starting here and going this direction, pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2 would be from 5 pi over 2 to 7 pi over 2. That is the left side of the circle. Okay. So then if I continue with group 7, I'm starting at negative 7 pi over 2. So I start here, negative pi over 2, 3 pi over, negative pi over 2, negative pi over 2, negative pi, negative 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2 is here. And going back to negative 5 pi over 2 would be going counterclockwise to here. So this is the left side of the circle. So guess what values we're going to be getting on these? And finally, group 8, 7 pi over 2. So we start here and we go in the counterclockwise direction because that's our positive direction. Pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2, 5 pi over 2, 6 pi over 2, 7 pi over 2 is right here. 8 pi over 2, 9 pi over 2 is right here. And I had to go this direction to get there. That is the right side of the circle again. So our tangent values, since the domains are the same in all of these, group 1, group 4, and 5, and 8 were all the right side, and group 2, 3, 6, and 7 were all the left side, what we're going to do is we're going to get the same values for our x's and y's, our y's. Our tan x. So here is the table for groups 5, 6, 7, and 8. Everybody should have gotten the same values for their tables, regardless of what group they were in. All right, so now let's go back to part 2. The tick marks on the axis provided are spaced in increments of pi over 12. Mark the horizontal axis by writing the number of the left endpoint of your interval at the leftmost tick mark, the multiple of pi that is in the middle of your interval at the point where the axis cross, and the number at the right endpoint of your interval at the rightmost tick mark. Fill in the remaining values at increments of pi over 12, which is what these tables are. Okay, so here is what you should be doing on this one. Here is the coordinate plane. And we're going up to 1, down to -2 here. And our domain is pi over 2. That's a negative pi over 2 to 3 pi over 2. So that is group 2. All right, so the x-axis from the one such set of marked axis on the interval pi over 2 to 3 pi over 2 is shown below. So if I were to do what the directions said, and what did it say to do? It said, mark the horizontal axis by writing the number of left endpoint, negative pi over 2, right endpoint, 3 pi over 2, and every increment of pi over 12 in between. Okay, so there it is. So now if I graph these, we need a larger y. So this is only going to 1 and -2. It needs to go from -8 to 8. But this is just showing what your axes should look like for problem number 2. Okay, so before I continue, let me go back to the last page here. And this here is positive. It's pi over 2, 7 pi over 12, 8 pi over 12, 9 pi over 12, all the way up to 3 pi over 2. They put a line here to show the y-axis, but the y-axis actually be way over here. So now I'm going to do it this way. So here is the y-axis over here. All right, so with that being said, here's my origin. Pi over 2 is right here. So if I put a tick mark there and there are my two endpoints. I am going to graph between pi over 2 and 3 pi over 2. And that's my group. This is group 2. So at pi over 2, something's going on there. We're not going to graph there, but this is pi over 12. So if this were 12s, that'd be 6 pi over 12, 7 pi over 12, 8, 9 pi over 12, 10, 11 pi over 12, 12 pi over 12 is pi, 13 pi over 12, and 15 pi over 12. And this would be 17 pi over 12, and 18 pi over 12 is 3 pi over 2. Okay, so our table though goes in 24ths. 13 pi over 24, well, that would be halfway, so that'd be right here. And it's -7. Here's -5, 6, 7, 8. So it would be approximately here. 7 pi over 12 is -3.73. Here's -4, so it'll be about here. 8 pi over 12 is 2 pi over 3. -1.73, which is about here. 9 pi over 12 is going to be at -1, which is right on that first mark right here. Here's -1. 10 pi over 12 is 5 pi over 6. That's -0.58, a little bit more than a half, so that'd be about here. 11 pi over 12 is -0.27, which is about -1/4, which is approximately there. And then pi is 0. And then we're repeating, but positive. So 13 pi over 12 is 1/4 almost. It's 27.27. And then 0.58 is 14 pi over 12 is a little bit more than a half. And 15 pi over 12 is at 1. 16 pi over 12 is 4 pi over 3. That's 1.73, which is about here. And 17 pi over 12 is 1, 2, 3, and almost 3/4, which would be here. And then 35 pi over 24 is halfway between these two. And that gave us 7.6. So 10, 9, 8, 7, a little bit more than a half would be about there. So then when I go to graph that, it would come up like so and go up like so. And this would continue down. So there we are from pi over 2 to 3 pi over 2. So there is the graph of the tangent function between pi over 2 and 3 pi over 2. Okay, so I brought a neater, better graph in that was graphed electronically. So there it is, stretched out a little better too, so it's not so short like mine was. All right, so number 4 says, what happens to the graph near the edges of your intervals? So what they're asking is, where did this graph go as we were getting closer to 3 pi over 2 and as we were getting closer to pi over 2, or whatever group you have? Okay, so near the edges of the interval, x approaches a value where the tangent function is undefined. Since cosine of pi over 2 plus some constant times pi equals 0 for any integer k, the tangent is undefined at the edges of the interval we are graphing. As x gets near the edge of the interval, sine of x gets closer to either 1 or -1, and cosine x gets close to 0. Thus, the tangent of x, sine x over cos x, gets very far from 0, either in the positive or negative direction. Very far from 0 would probably be infinity, maybe. Number 5, when you are finished, affix your graph to the board in the appropriate place, matching endpoints of intervals. Okay, so in this group activity, what you were to have done is graph all of these. Okay, and then affix it to a board so that everybody can see what everybody graphed from all of the intervals. All right, so what you should have seen would be, and let me bring it in. Okay, so if everybody did everything correctly and got the right values and graphed it correctly, the graph that I'm showing you up here was from pi over 2, which is here. So the one that I showed you was group 3, I believe. Group 2. Group 2 should have had this one. And there was how many groups? 1, 2, 3, 4, 5, 6, 7. I think there were 8 groups. Anyway, that's what they should have looked like. So this was group 2 and so on. So they all look the same. They're just shifted over by a distance of pi. So H would be pi. All right. Let's get rid of that. Let's get rid of this. All right. So exploratory challenge 2, exercises 6 through 16. For each exercise below, let m equal the tangent of theta be the slope of the terminal ray in the definition of the tangent function. And let p equal x sub 0 comma y sub 0 be the intersection of the terminal ray with the unit circle after being rotated by theta radians. For theta being between 0 and pi over 2. We know that the tangent of theta is the slope m of line OP. Okay? So number 6 says, let Q be the intersection of the terminal ray with the unit circle after being rotated by theta plus pi radians. So if P is here at theta, theta plus pi would put Q over here. And it says, what is the slope of OQ? Well, the slope of OQ would equal the slope of OP. Okay, so point P, O, and Q are collinear, meaning they're on the same straight line. So the slope of OQ is the same as the slope of OP. Thus, the slope of line OQ is also m, which they told us up here. Let m equal the tangent of theta, be the slope of the terminal ray. Another approach would be to find that the coordinates of Q are negative x sub 0 comma negative y sub 0. So the slope of ray OQ is y sub 0 over x sub 0, which is m. B says find an expression for tangent of theta plus pi in terms of m. Okay, so tangent of theta plus pi would put us over at Q. So it equals m as well because it's collinear, like we said in part A. So an expression for tangent of theta plus pi in terms of m is tangent of theta plus pi equals m. All right, part C says to find an expression for tan theta plus pi in terms of tan theta. Well, if tan theta is equal to m, then I can just substitute that in, and there it is. Tan theta plus pi equals tan theta. D says, how can the expression in part C be seen in the graph of the tangent function? All right, so the pieces of the tangent function repeat every pi units because the tangent of theta plus pi equals the tangent of theta. All right, page 4 brings us to number 7. Let Q be the intersection of the terminal ray. So let's just walk through this. Where's Q? Q is right here. So the terminal ray is OQ. Let Q be the intersection of the terminal ray with the unit circle after being rotated by negative theta radians. What is the slope of OQ? Okay. Well, the slope of OQ would be ray OQ is the reflection of ray OP across the x-axis. So the coordinates of Q are x sub 0, or x naught, comma, y naught, negative y naught. Thus, the slope of OQ is the opposite of the slope of OP. Thus, the slope of OQ is negative m. Okay? B says, find an expression for the tangent of theta, tangent of negative theta in terms of m. Well, if this is equal to m, then the tangent of negative theta equals negative m, since it's the opposite of the slope of OP, which was m. Part C says, find an expression for tan negative theta in terms of tangent theta. Well, if tangent theta is negative m, then tangent of negative theta is equal to the negative of tangent theta. So tan negative theta equals negative tan theta. D says, how can the expression in part C be seen in the graph of the tangent function? Okay, well, the graph of the tangent function has rotational symmetry about the origin. Okay, so it's symmetric and rotated. 8, in the tangent function, an even function, an odd function, or neither. So is the tangent function even, odd, or neither? How can you tell? Your answer is correct from the graph of the tangent function. All right, so keep in mind that when we have an even function, then it's a reflection across the y-axis. And if it's an odd function, it's a reflection across the origin. All right, so let's go back and look at that graph. Where did it go? Where is my tangent graph? I think I might have deleted it. Oh, it's right here. So if it got reflected across, there'd be a point here. If it were even, it'd be reflected across the y-axis. If it's odd, it's reflected across the origin. So tangent looks like it is an odd function. So because tangent of negative theta equals the negative tangent of theta, the tangent function is odd. So that's the other thing. If you plug in a negative x and get a negative function, then that's another algebraic way of showing that the function is odd. If the graph of the tangent function is rotated pi radians about the origin, there will appear to be no change in the graph. Number 9, let Q be the intersection of the terminal ray. Okay, so now we're dealing with Q in the third quadrant, or second quadrant right here, second quadrant. All right, let Q be the intersection of the terminal ray with the unit circle of being rotated by pi minus theta. So this whole thing is pi. Take away this distance of theta and we are only here. What is the slope of OQ? Well, if this is the point x comma y, this is the point negative x comma y. So the only thing that changed would be the sign. So I hope you know what's coming. Ray OQ is a reflection of ray OP across the y-axis. So the coordinates of Q are negative x naught comma y naught. So therefore the slope of line OQ is the opposite of the slope of line OP. So the slope of line OQ is negative m. B says find an expression for tan of pi minus theta in terms of m, and that is tan of pi minus theta equals negative m. Part C says to find an expression for tangent of pi minus theta in terms of tangent theta. So it would be tan theta and negative tan theta in place of m. So we get tan of pi minus theta equals the negative of the tangent of theta. All right, page 5, number 10. All right, so it says, let Q be the intersection of terminal ray with unit circle after being rotated by pi over 2 plus theta. So that'd be pi over 2 to here plus that same distance theta would get us to here. What is the slope of OQ? Okay, so this would be over P, or over X naught up Y. Rotating it 90 degrees, where does that put us? So if I went over 1, up 1, and I rotated 90 degrees, it'd be, instead of being at the point 1, 1, we'd be at the point negative 1, 1. So what changes is, if I went over, let's say I went over 2, up 1, rotate it 90 degrees, that's going left 1, up 2. So the X and Y change, and the X becomes negative. Did you follow that? So what I'm saying is, if we're going to rotate 90 degrees, some point on our graph that was X comma Y is going to end up being Y comma negative X. So if this is X naught, Y naught, so if I put little naught symbols down here, it is going to become Y naught comma X naught, negative X naught. Okay. So what is the slope? Ray OQ is a rotation of ray OP by 90 degrees counterclockwise. So line OQ is perpendicular to OP. Thus, the slope of OQ and OP are opposite reciprocals. Thus, the slope of OQ is negative 1 over M. Okay? B says, find an expression for tangent of pi over 2 plus theta in terms of M. Hopefully you see a pattern here. So the tangent of pi over 2 plus theta equals a negative 1 over M. Okay, it doesn't equal M, it doesn't equal negative M, it's equal to the negative reciprocal because it's perpendicular. C says, find an expression for tangent of pi over 2 plus theta, first in terms of tangent theta, then in terms of cotangent theta. Okay, well, tan of pi over 2 plus theta would equal the negative of 1 over the tangent of theta, and that is the negative of cotangent theta. Number 11, let Q be the intersection of the terminal ray with the unit circle after being rotated by pi over 2 minus theta. So in other words, go over pi over 2, but then take away the same angle measure of theta over here. So it's moving it this way, a distance of theta from the y-axis. What's the slope of OQ? All right. Well, ray OQ is a reflection of OP across the line y equals x. If I drew a line y equals x, let me do that. So let's draw a straight line. Let's make it red and thin, not dashed. And if I go through here like so, this is the line y equals x. One slope of 1. So it's a reflection across that line. So the coordinates of Q are y naught, x naught, then the slope of OQ is 1 over M. Okay? Find an expression for tangent of pi over 2 minus theta in terms of M. Well, that would just simply be tangent of pi over 2 minus theta equals 1 over M. Part C says to find an expression for tangent of pi over 2 minus theta in terms of tangent of theta or other trigonometric functions. So the tangent of pi over 2 minus theta equals 1 over the tangent of theta, which is equal to the cotangent of theta. So it's the same as C up here, except the slope's positive in this quadrant, not negative. So cotangent's positive in quadrant 1. Number 12, summarize your results from exercises 6, 7, 9, 10, and 11. All they're asking us to do here is say, okay, well, first of all, let's give some parameters. So we'll say for theta being between 0 and pi over 2, I meant to put theta here. So for 0 to pi over 2, in other words, in the first quadrant, what are we going to get? Well, we're going to go back to exercise 6, which is here, and we're going to look at part C. And this is the summary. We found out that the tangent of theta plus pi is equal to the tangent of theta. So I'm going to copy that and bring it back to our summary page, and I'm going to paste it right here. All right, so there's number 6. We're summarizing. So that's what we found out in 6. Well, what did we discover in 7? So I'm going to go back to 7, and it's right here. The tangent of negative theta equals the negative of the tangent of theta. So I'm going to add that to my summary. So that goes here. All right, now let's go on to number 9. Number 9, part C says the tangent of pi minus theta is equal to the negative of tangent of theta. All right, so that's part of our summary. Exercise 10, part C, what did we conclude? Well, the tangent of pi over 2 plus theta equals the negative of tangent of theta, which is equal to the negative of cotangent of theta. So that's part of our summary. So I'll put that right here. All right, and finally, number 11, part C says, the tangent of pi over 2 minus theta is equal to 1 over the tangent of theta, which equals the cotangent of theta. So there is our summary of what we have discovered in this lesson. All right, page 6, number 13. We have only demonstrated that the identities in exercise 12 are valid for theta being between 0 and pi over 2 because we only used rotations that left point P in the first quadrant. Argue that tan of negative 2 pi over 3 equals negative tan of 2 pi over 3. Then, using similar logic, we could argue that all of the above identities extend to any value of theta for which the tangent and cotangent of the last two is defined. All right, so here's the argument. By the property developed in exercise 3, we have the tangent of pi over 3 would equal the negative of tangent of pi minus pi over 3, which equals the negative of tangent of 2 pi over 3. Okay, because the terminal ray of a rotation through negative 2 pi over 3 radians is collinear with the terminal ray of a rotation through pi over 3 radians, that would justify that the tangent of pi over 3 is equal to the tangent of negative 2 pi over 3. Thus, by transitivity, we have the tangent of negative 2 pi over 3 has to equal the negative of the tangent of 2 pi over 3. Okay. Number 14, for which value of theta are the identities in exercise 12 valid? So using a process similar to the one we use in exercise 13, we could show that the value of theta can be any real number that does not cause a 0 in the denominator. The tangent function is only defined for theta not equal to pi over 2 times pi times some constant for all integers k. Also, for those identities involving cotangent theta, we need to have theta not equal to pi times k for all integers k. All right, so we don't want to choose values that are at 12 o'clock or 6 o'clock in a circle. Number 15, derive an identity for tangent of 2 pi plus theta from the graph. So let me bring the graph in. Okay, so here's the graph of tangent again. And so it says to derive an identity for tangent of 2 pi plus theta. Well, if theta is 0, then we'd be right here. So if we just went to the right a little bit, and let's just say theta was right here, that's 2 pi plus a theta. If we shift over to here, it would end up right here. And if we went over further right here, so in other words, get rid of the 2 pi, then the tangent of theta would be here. The tangent of pi plus theta is here. The tangent of 2 pi plus theta is here. Let me get rid of this dot. Okay, so what can we conclude from that? Because the terminal ray for a rotation by 2 pi plus theta and the terminal ray for a rotation by just simply theta coincide, this one and this one, we see that the tangent of 2 pi plus theta equals the tangent of theta, where theta does not equal pi over 2 plus some constant times pi for all integers k. Because what happens there? Well, here's pi over 2 right here. What's the value of theta? I mean, what's the value of tangent? As we're approaching pi over 2 from the left side, it's going to positive infinity. And as we're approaching pi over 2 from the right, it is approaching negative infinity. So we have something going on there that we'll get into later this year. Number 16, use the identities you summarize in exercise 12 to show that the tangent of 2 pi minus theta equals negative of tangent of theta, where theta does not equal pi over 2 plus some constant plus pi for all integers k. Okay. Well, from exercise 6, we received, instead of going back and getting them, I brought them all together. From exercise 6, tangent of 2 pi minus theta equaled the tangent of pi plus pi minus theta, which equals the tangent of pi minus theta, since if you just add a pi to it, it's the same. And therefore, that is equal to the tangent of negative theta. From exercise 7, the tangent of negative theta equals the negative of the tangent of theta. So therefore, we can conclude that the tangent of 2 pi minus theta equals the negative tangent of theta for theta not equal to pi over 2 plus some constant times pi for all integers k. All right. Okay, page 7, I think it's 7, brings us to the end of lesson 14. Review this lesson summary and go to your problem set.